Example 3, it asks us to find the equation of the tangent to this curve at the point where x equals a half. Now, there are two things that are different in this example from before. First of all, the curve itself, this time we've got x in the denominator. So we're going to have to prepare this for differentiation at some point. So we're going to have to slide this x to the top line. So that's the first thing. So we'll maybe do that now. So copy down our 4x and our minus. And then again, we're going to just slide the x only. Only x is going to the top line. If x is in the denominator, or any denominator, we can only slide it to the top. So that's going to give us minus 1x to the power of minus 1, or just x to the power of minus 1. So that's important for starters. The second thing is that it's very difficult to sketch this curve, but that isn't a problem. And we only sketched the curve in the first two examples to get us to appreciate what's happening. We're now fully understanding of the process, so there's no need to sketch the curve. However, we're only given the x coordinate of the point that the tangent goes through. We need to get the y coordinate of the point as well. Now, in order to do that, you sub the x coordinate into the curve because the point lies on the curve. So, first thing we're going to get is the y coordinate of the point. So, get the y coordinate of the point, go back to your curve and replace everywhere you see x with a half. So we're going to get y equals 4, and then upon a half, minus 1 over, I'm subbing it into the curve before I brought x to the top line, 1 over a half. So let's tidy it up. 4 times a half will give us 2, and then we are subtracting 1 divided by a half is also going to give us 2, so we're actually going to get 0. So the y coordinate of the point is 0. So now I'm going to write down what the point actually is. So the point is a half 0. So establish what the point is before we start differentiating. Okay, so we want the equation of the tangent. We need to get the actual gradient of the tangent in order to do that. So there's that word gradient. That means differentiate. So we're going to go to our curve and we're going to differentiate. So let's put tangent down. And the first thing we're going to do is get the general gradient. dy by dx. So let's differentiate the curve. So dy by dx, that's going to equal. So differentiate 4x, we're just left with 4. Differentiate negative x to the power negative 1, so multiply the term by its power. So a minus multiplied by minus 1 is just going to be plus 1. So we're going to have plus 1x to the power of minus 2. In other words, plus x to the power of negative 2. What I'm now going to do after I've differentiated is I'm going to bring x back to the bottom line to make its power positive again, because we're going to be subbing values into it very shortly. So that's going to give us 4 plus 1 over x squared. Okay. Now, we want to get the actual gradient of the tangent at the point where x equals a half. So actual gradient at x equals a half. So chuck a half into the general gradient, so we're going to get 4 plus 1 over a half all squared. So that's going to give us 4 plus 1 over half squared is a quarter. So we've got 4 plus 1 divided by a quarter is just 4. So that's going to give us 8. So that is the actual gradient of the tangent to the curve at the point where x is a half. So now we can get the equation of the tangent. So equation. So we know that the tangent goes through the point a half 0. And we know that its actual gradient down here is 8. So again, we're going to label the point x1, y1, and we're going to chuck all the information into the brand new equation of a straight line. So chuck the info in, we're going to get y minus nothing, and that's equal to 8 upon x minus a half. Multiply bracket through by 8, so we're going to get y equals 8x minus 4. And you know what? That's a perfectly acceptable way to leave it, unless it specifies what way to leave it. If it said give it in the form ax plus by plus c equals 0, where a, b and c are integers, then we'd move 8x and minus 4 over. Or if it said give it in its general form, we would also move 8x and minus 4 over. Okay, but that is perfectly acceptable. So that is the equation of the tangent to this curve at the point where x equals a half.